Okay, students, I want to explain, in this case, the solution of exponential equations. But I want to explain this solution of exponential equation using two different ways. One way is just using the equality of exponent theorem, and the other way is using logarithms. First, I will explain the equality of exponents theorem. In this theorem, we have that if b to the power of x is equal to b to the power of y, that means if we have an equality between two exponential expressions with the same basis, right, then the exponents are equal. Then we can just set up an equation, making both exponents, x and y, equal. For example, suppose you have the equation 2x minus 3, 2 to the power of 2x minus 3 equals to 2 to the power of x plus 5. And we want to solve this exponential equation. To solve this exponential equation, we are going to look at the bases. We have in this case that both bases are equal. In both cases, you have base 2 and base 2. Then you are ready to make your exponents equal. You say then 2x minus 3 equals x plus 5. Solving now the linear equation that we get 2x minus x is equals 5 plus 3. We bring this x to the left, subtracting, we bring the 3, adding to the right. Then 2x minus x will be x, and 5 plus 3 will be 8. Then in this case, the solution of the exponential equation is x equals 8. When you look at the second case, in this second case, we have different bases. The question is if I can do a transformation, over my equation to get the same basis. I know that 27 is 3 times 3 times 3. That means it's 3 to the third power. I'm going to substitute then the 27 by 3 to the third power, and I get 3 to the power of 2x minus 1 equals to 3 to the third power, to the power of x minus 5. Remember that we have a property of exponential expressions that if we have x to the m, you multiply the exponents and you get x to the m times m. Then this is what I'm going to do in this case. I'm going to multiply 3 times x minus 5. And then we get here 3 to the power of 2x minus 1 equals to 3 to the power of 3 times x minus 5 multiplying the exponents. This would be 3 to the power of 2x minus 1 equals to 3 times x, is going to be 3x. 3 times negative 5 would be negative 15. And now we got two exponential expressions with the same basis. Then we are ready in this case to make the exponents equal. Then we're going to do 2x minus 1 equals to 3x minus 15. Then we solve this exponential equation, and when we solve, this linear equation, and when we solve the linear equation, we get 2x minus 3x. We bring the 3x to the left, will be equals negative 15 plus 1, right? 2x minus 3x will be in this case negative x equals negative 15 plus 1 will be negative 14. Then we divide or multiply both sides by negative 1. We get x equals positive 14. In this case, the solution of the equation is positive 14, right? And now we have one more exercise. In this case, in this second exercise, let me bring this solution to the other part, just to have a space here to solve this equation. And we put this solution here. And now you know, right, that this will be the solution. This will be the final part of this exercise. And now we have this case. There is 2 to the power of 3x equals 1 over 16 to the power of 2x plus 7. What is going on in this case? Again, we have different bases. Wow, but in this case I have a fraction. Well, let me see what transformation can I do in order to get the same thing on both sides. I have 2 to the power of 3x, I have base 2 here, and I have 1 over 16. Can I just break down the 16 into an exponential expression base 2? Yes. Why? Because 16 is 2 times 2 times 2 times 2. That is the same as 2 to the power of 4. We're going to substitute the 16 that is the denominator here by 2 to the power of 4, and we get 2 to the power of 3x equals 1 over 2 to the power of 4, to the power of everything, to the power of 2x plus 7. I know a property of exponential expression. There is this: x to the power of negative n is 1 over x to the power of n. That means if I have a negative exponent, I can just bring the whole exponential expression as the denominator of a fraction with numerator 1, and then the exponent will be positive. I can use, the same property in the reverse direction. That means I can just bring this up, putting the exponent negative, and then we get here 2 to the power of 3x equals 2 to the power of negative 4 times 2x plus 7. Why? Because I'm going to bring, in this case, the 2 to the 4 up using the exponent negative. Now I am going to multiply negative 4 times 2x plus 7 using this property that I mentioned before, and I get 2 to the power of 3x equals 2 to the power of negative 4 times 2x is negative 8x. Negative 4 times 7 is negative 28. Now we have the same basis. We can do 3x equals negative 8x minus 28. We bring this minus ax to the left, and 3x plus 8x equals negative 28. This will be 11x equals negative 28. And then we isolate the x is equals negative 28 over 11. In this case, my solution is negative 28 over 11, because you cannot simplify 28 over 11. Okay? Then, as we cannot simplify 28 over 11, then my solution would be negative 28 over 11. Let me move the camera a little bit so that you can see the solution in this case. Right? Then the solution is negative 28 over 11. As you see, I have solved, in this case, 3 exercises using the equality of exponent theorem. Now, in the next video, we're going to see how to solve exponential equations using logarithms.